my name is Joy Bloomwini. I am a poet of code, and I tell stories that make daughters of diasporas dream and sons of privilege pause. But I'm also a computer scientist, and today I'm going to share with you how I started addressing issues to do with algorithmic bias. So in my first slide, you'll see a term that I call the coded gaze. And the coded gaze, like the white gaze or the male gaze or the post-colonial gaze, is a reflection of the priorities, preferences, and at times prejudices of those who have the power to shape technology. And I first really started thinking about this as I was working on an art installation, and something didn't quite go according to plan, as you'll see in this demonstration. So you'll see here, I have my lighter skinned friend's face, no problem. I try to get detected. I need a little assistance, right? And so this experience of coding in a white mask is what led me to start questioning facial analysis and recognition systems and more broadly artificial intelligence. So I shared this experience with the TED audience, got over 1 million views, and I thought somebody might want to check my claims. So let me check myself, and I ran my TED profile image through AI systems from a range of companies. Some didn't detect my face at all, and the ones who did labeled me male. I'm a phenomenal woman. I am not a man. So that was not the ground truth. And so, as annoying as this was, being detected by technology that can be used for mass surveillance is not always what you actually want. And so as I learned in the US that 1 in 2 adults, over 130 million people, has their face and facial recognition networks, I got concerned when I learned that these systems can be deployed unwarranted with systems that haven't even been checked for accuracy. So what happens when you're misidentified as a criminal suspect? And in the UK, where performance metrics are being recorded, the numbers don't look so great. You have false positive match rates over 90%, more than 2,400 innocent people being matched with criminal suspects, and you even have 2 women who were falsely matched with men. So my earlier example has real-world implications. And as we talk about the future of work and how AI will replace jobs of the future, we cannot forget that AI is now serving as the gatekeeper for current jobs. So here's a company called HireVue, and they also use facial analysis technology. And they say, give us a video of a face, and we can pick up verbal and nonverbal cues to tell you things like emotional engagement and problem-solving style. And here's the kicker. We train on the current top performers of our company. For me, when I heard this, I was thinking, do they know they could be in violation of Title VII of the Civil Rights Act, which says you can't discriminate on the basis of gender or color when it comes to the workplace and employment? And we're not just talking about using computer vision or facial analysis technology. We really have to think about all of the areas in which AI is currently being used. So this includes hiring, but also college admissions. And we know that can be biased, as well as access to financial services. And even when we're thinking about things like predictive policing, who has access to freedom. And so because of the widespread use of AI for my MIT thesis, I decided to investigate the accuracy of facial analysis systems when it came to guessing the gender of a face. But before I could even begin, I ran into a problem. Many of the benchmarks that are used to say how well we're doing with facial analysis tasks like detection or gender classification are themselves skewed. So here you're seeing metrics from a benchmark from the National Institute for Standards and Technology. It's 75% male, 80% lighter skinned individuals. So for me, these pale male benchmarks are really destined to fail the rest of society if we don't address them. And the question is, how did it come to this? How did we end up with such skewed benchmarks? And this is something I call power shadows. So essentially, if we're not intentional about being inclusive, what we'll do is we will reinforce existing inequalities. So if you look at the way that benchmark was derived, they use public figures. So now let's think about who's represented in the public. Let's look at the representation with parliamentarian members. You're at 77%. So it's not so surprising then that the patriarchy becomes a power shadow on these data sets. Similarly, which images are going to be most accessible? Which media representation are we going to see? You're going to see more lighter skinned individuals. So as we're thinking about our AI presence and future, we need to make sure we're addressing these power shadows. And so I created a new benchmark that was more inclusive when it came to gender parity and also when it came to skin type distribution. So I could finally get to my research question. How accurate are IBM, Microsoft, and Face++, a billion-dollar tech company in China, when it comes to guessing the gender of a face? And if you look at the accurate measurements, it seems okay if you look at the aggregate accuracy. 88%, not so great, but not horrible. 94%, 90%, maybe you get a B depending on the grading scale. But now let's look at gender. And when we break it down by gender, we see that all systems work better on male faces than female faces in our data set. And when we look at skin type, we're seeing that all of the systems in aggregate work better on lighter skin than darker skin. Then we took it a step further and we broke it down by intersection. So not just looking at gender, but also looking at skin type. And skin type instead of race, because I could be Black, Mariah Carey is Black, we're on a different spectrum when it comes to the actual shade. So this is why we look at skin type in particular. And what we see here with the intersectional breakdown, there's perfect performance for one group, the pale males, flawless performance. 98% for lighter females, 94% for darker males, and then we're at closer to 80% when it comes to darker females. These were the good results. Let's look at Face++. China's supposed to have the data advantage, but the type of data you have really matters. And also you see here why it's important that you do an intersectional analysis, because here we're seeing that's actually darker males that have the better performance, lighter females at 94%. And now we've dropped to 65% accuracy, commercially sold product. IBM, again, we're seeing their differences, right? If you're comparing darker males or lighter females, again, why an intersectional analysis is important, because different companies will perform in various ways. And if we break it even further and we split it by the actual skin type, we get error rates that get close to a coin toss. We're talking binary classification. You have a 50-50 shot because we've reduced gender to a binary. And here we're getting accuracy, error rates around 47% for the highly melanated. So I thought companies might want to know, and I shared the results with the companies I audited. And IBM was the most responsive company in terms of getting back to us quickly. Microsoft did as well a bit later. And what we found is on the day we released our research, IBM also released a new product. And as you can see here, it was much improved. So this was the gender shade study, and I want to talk about three main takeaways. The first is intersectionality matters. We can fool ourselves into a false sense of progress if we're only looking at aggregate data. And also, even if we do single axis analysis, okay, we got the gender thing, oh, we got the skin type thing, but did you do the intersection? You might find something out. Also, we're fooling ourselves by having supremely white data sets that exclude a group I like to call the undersampled majority. So oftentimes I'm reading about minority, marginalized group, and I'm like, women and people of color? Last I checked, that's most of the world, right? And another takeaway, change is a matter of priority. I can't tell you how many people saw my TED Talk and they're like, yeah, but you know, you dark skinned, like that's why you weren't being picked up. The laws of physics, there's only so much that they can do. The laws of physics did not change between December 2017 when I sent IBM the results and February 2018 when they did the update. What changed is they made it a priority. And so after Gender Shades came out, there was a lot of media coverage, over 230 articles in more than 37 countries. we did a follow-up. We wanted to see not only how did our target companies from the first study do a year later, but we wanted to include non-target companies as well. So we brought in Amazon, since they were selling to law enforcement and are being trialed by the FBI. And we also included Kairos, whose founder had been talking about the importance of diversity and inclusion, and he was the Black CEO of the company at the time. So let's see what happens a year later. We see that for all of the target companies, there are improvements. And for the non-target companies for our 2018 test, they were a bit closer to the 2017 results of their peers. And here we see that in our follow-up, all target companies reduced the gender gap substantially. But when it came to non-target companies, again, we're where the others were a year before. Similarly, skin type, we're seeing reductions with the target companies. When it comes to the non-target companies, not so much. And then when we do the intersectional analysis, flawless performance for yet another group, the pale males again. And what are we seeing with darker females? Again, closer to the peers a year ago. And so here I call out Amazon in particular because they had the worst performance overall in our 2018 August audit. And you can see how Microsoft compares to Amazon. And here you can see Face++, again, billion-dollar tech company in China. They're making these gaps and they're closing them as well. And then finally, we can look at the comparison to IBM. So our approach of releasing the information to the companies beforehand and giving them a chance to respond seemed to be better than the second option, which was we'll do the audit and then we'll share it publicly. So after we shared our research, Amazon attempted to discredit it. However, you had a year of replication from other tech companies as well as academics. Now, even if companies improve their systems and you have accurate AI, it can still be abused. Here's a story that came out from The Intercept showing that IBM had equipped the New York Police Department with video analytics that could search for people by their skin color, but also their facial hair, the color of clothing that they were wearing. So we really have to think not just about accuracy, but the potential for abuse. And this is why I launched the Safe Face Pledge last year in December to say, what would it look like to create a world with more ethical and responsible facial analysis technology, where we show value for human life and dignity, where we address bias continuously, where we facilitate transparency, and most importantly, actually embed this in our business practices, in our contracts, in our terms of services. And I'm excited that 3 companies have come on board. And it's not just companies saying we're going to develop in a more ethical and inclusive way. We also have other companies that are saying we'll only purchase from safe face companies. So all of us can be part of shifting the narrative of AI so we can bend towards more inclusion and we can bend towards justice. Thank you.